Okay, so we are graphing a system of equations. And one thing to know is that that doesn't mean something really extravagant or big. To me, a system sounds like something more than it is. It's just two equations. It could be more than that, but if you're just learning about it, it's two equations. That's all it means. So essentially, we're going to graph the first equation, and then we're going to graph the second equation, and then we're going to see what we notice about the two graphs. If they intersect, then there's a solution. And if there's not, then we can talk about that. Okay, so let's start with the first one. So y equals x plus 4. So right now you've been graphing some lines, and keep in mind the y equals mx plus b formula. You've seen it many times by this point. And I like to think of the b as saying begin here, begin at 4. That's the y-intercept. So we begin at 4 on the y-axis. And then the slope, m is the slope. And so in front of that x, there's an understood 1. And remember, slope is rise over run. So if the slope is 1, that means 1 over 1, right? 1 divided by 1 is still 1. So it means rise 1, run 1. So I can go up 1 and right 1. Yes, up 1 and right 1. Or I can go down 1 and left 1, down and left, down, left, just like that. And then you've got a nice line. So you want to connect the 2 points, or all of the points that you've plotted, and put arrows at both ends. Okay. So we've got the first one. Now let's do the second one. We've got y equals negative 1/2 x plus 1. So real quick, something to note is that this is a negative slope. I know that this one's going to be more like this. A negative slope is going to go in that direction. So I need to make sure that when I graph this, like I keep the slope in mind. So begin. This time I begin at positive 1. So begin at 1 on the y-axis. And my slope now, rise over run, but this time it's negative 1 over 2. So rise negative 1. I'm gonna go down 1 and run 2. Down 1, run 2. And think, I could have also gone up 1 and left 2. Ooh, that's a good point. Up 1, left 2. And so either way, I'm creating this nice line here that has an intersection through the other line. Now, yours is an approximation, so it's okay if it's not perfect. Like mine is not perfect. Let me show you the finished one there. Okay, so there's the nice, neat one. But notice the answer to this question is that the solution is at negative 2, 2. Negative 2, 2, this is where our intersection is. These two graphs intersect at one point. When it says solve, it's actually saying find a solution to this question. The solution is where they intersect, and that is at negative 2, 2. So solutions to systems are coordinate points, and you found it by graphing. Hope that helps. I'll see you next time.